So how to find out the radioactivity value of any element, radioactive element, artificially how they are going to be developing here. Is there any relation between those that you have to discuss? So that is related to the block 3 in unit 9. Next, block 4 here. What are the properties of nuclei? Different properties are there. Nuclear model, liquid drop model is there, shell model is there, magic numbers. Okay. So all which is comes under the nuclear models. So that is out of these three, one question is to be giving to you. Whether it is a set or B set or C set, whatever it may be, they may be asked. Next, in unit 11, you need to know about that. What is nuclear fission and nuclear fusion? What is nuclear fission? A heavy particle which can be divided into a tiny, that is fission, and small particles which can combine and forming a big one, that is related to the fusion. Okay. In the case of fusion, only maximum energy which is to be releasing here. So that is related to the here nuclear fission and fusion. That should be discussed in the case of unit 11. And also in nuclear reactor is also to be discussed in unit 11. Nuclear fission and fusion. After discussing these two definitions, we need to know about that what is nuclear reactor. Okay. How the nuclear reactor which released the energy, what is the chain process which is to be involving in this, and each and every here neutron which can gives the how the emitting the 3 neutrons. Okay. So that is to be discussed in the case of nuclear reactor. Finally, last one is the elementary particles. Okay. So in this elementary particle, we need to know about that. What are the mesons, pi mesons, and also bosons and fermions. All these comes under the elementary particles. So you need to know, characterize the elementary particles. Okay, Randy? So that is to be discussed. So this is about the modern physics. So in this modern physics, 4 blocks. This is a first one under the spectroscopy, and the spectroscopy, atomic, molecular. Next, elements of quantum mechanics, nuclear structure, and properties of nucleus. So all which we have to discuss in only 8 classes. This is only counseling class. We will discuss. Okay. Next. Yeah. So in Bohr's theory, first unit, in spectroscopy, Bohr's theory and line spectra. Okay, not line spectra. So what is line spectra? What is Bohr's theory? Sommerfeld theory? Energy levels of hydrogen atom. Hector atom is a question. And Planck's experiment, like that. So here you need to know about that. Why do we studying this? So how the energy which is to be distributed in the case of a continuous spectra of a black body, and which could not be explained the classical theories. Later on, Max Planck, he was introduced a revolutionary concept about the radiation quanta, that is E equals to h. So that is in the beginning of the century, the entire process which should be takes place regarding as a line spectra of atoms and molecules. And here the whatever the data which is to be available on the wavelengths of the line spectra, a certain relations which was discovered and empirically between the frequencies of various lines in the elements. Also, these relations which is to be pointed out that the origin of the characteristics line spectra might be due to some fundamental mechanism which is common to the all atoms here. So the line spectra due to the hydrogen has been studied. So and also developed the structure of the atom which is led to the Bohr here. Okay, that can gives the theory of the atomic structure. So here we have to develop and study the development of the empirical laws of the spectral series, Lyman, Balmer, Paschen, Brackett, Fund. Okay, these are the spectral series which is related to the here hydrogen atom, and also Bohr's theory in explain the line spectra due to hydrogen atom. So we have to study about the vector atomic model. Okay, and also we have to derive the critical points regarding this, so that you have to see that the figure how the line spectra which gives you, so that which may be employed that atomic spectra. So how the atomic spectra which gives. So here S is a source here, S1 is a slit, and P is a prism, and PP is a photographic plate, FPP is a front view of the photographic plate. So here you need to know about that whenever such a radiation which is to be incidenting upon the ear, a sample, so that how the emission spectra which will gives, how the absorption spectra will gives you. Okay, so here absorption spectra which is not in a clear position, whereas if it is to be emitting here, that means emission should take place from the higher to the lower energy level, the atom which is to be jumping here there only, which can release the energy, and the energy which can be seen by the spectrometer here, there also which can give the line spectra. There it can have H alpha, H beta, H gamma, H delta, like that, different wavelengths which is to be emitting here. So hydrogen spectra is a line spectra. So you need to know about that. So that's what here in visible region, what do you observe here? In ultraviolet, visible IR. Okay, so let that is a case for the hydrogen spectra H alpha, which is started from the red color. That means 6563 near approximately 7000 Armstrongs wavelength, which is to be emitted here up to the your visible region, which is to be giving out here. You need to know that. You have to discuss. And also, what is the Balmer friend series fund when n equals to 1 according to the Rydberg constant here? So 1 by n1 square minus 1 by n2 square, that is the formula here. R into RH is the Rydberg constant. So by substituting value, you can have different spectras that you have to follow. Next, Bohr's theory. Who proposed this? In 1913, Niels Bohr, he was proposed the theory of the hydrogen atom, and they can give the explanation of the Balmer series of hydrogen, and also so what are the postulates which was given by the Bohr's here? You need to know that. What is that first postulates you need to know? The electron, an electron in an atom which can move in a circular orbit. Who proposed this? Bohr. Okay, around the nucleus under the influence of the Coulomb's attractive forces. So that Coulomb's attractive forces means nucleus is a positive, around the nucleus electron is a negative charge. So definitely what is the Coulomb's law here? The force of attraction or repulsion between any two charges, that is always proportional to the magnitude of the product of the magnitude of the charges q1 and q2, and also inversely proportional to the square of the distance between them, 1 by r square. That is F is proportional to q1 q2 by r square. That is a Coulomb's attractive forces between the two electrostatic charges. So what are the charges are here? Nucleus of the hydrogen atom, which is a positive. Around the nucleus, electron is a negative. That's what here electrostatic charge. So that you have to know about that Coulomb's attraction between the electron and the nucleus obeys the classical mechanics. And also here most important second one is that the instead of infinity of orbits which would be possible according to the classical mechanics, and also it is assumed that the electron moves in an orbit for which its orbital angular momentum capital L value, which is an integral multiple of h by 2 pi. H is a Planck's constant. L equals to h by 2 pi. Okay. And the next one, even though the electron which is constantly accelerating, uh, an electron moving in such a loud orbit state does not radiate electromagnetic energy. Okay. So this is the third one here. The energy remains constant. So that these allowed orbits, you can call it as a stationary orbits. Next, fourth one. When the electromagnetic energy which is emitting an electron, initially which is moving of orbit total energy, even is discontinuously changes its motion, so that it moves an orbit of the total energy E gamma, and the frequency of the radiation emitted, which is given by E1 minus E2 or E2 minus E1 by H, where E1 and E1 is the first stationary orbit energy and E2 is the second stationary orbit energy. That you can call it as a delta E, that is nothing but E2 minus E1. Okay, that is divided by Planck's constant. So these are the postulates you need to know about that. And also this essay question we will discuss tomorrow's class. Okay. Uh, so this is about the introduction and as well as the what is the Bohr what do you say here? What is the line spectra according to the Bohr's theory, hydrogen spectra, what is the Rydberg constant? We have been discussed. So tomorrow we'll discuss the essay question. Okay. Right. All the best.